So I managed to get the motor control working for this chunk of inkjet printer using something called position integral derivative, or a controller modeled on position integral derivative. The motors, just to talk about what this thing is, we got a DC motor, standard DC motor. There's a little gear and belt drive here, and it's turning this big wheel, which is an encoder. It's got very fine 200 line per inch rules around the outside edge, and this guy right here is a quadrature encoded, or quadrature output optical encoder. There's an LED inside there that shines through this, the ruled edge of the film, and there's two sensors inside that detect changes in the LED output as it as the rulings, as the transparent and opaque parts of the wheel go past it. So it's actually counting all the way around. Each rotation of the wheel is 1800 lines. Because of the way the quadrature encoding works, you can actually encode 4 times that, but I'm only using half of that, so it's 3600 counts all the way around. Then I got an Arduino with one of the wonderful Adafruit motor shields on it. This is hooked up to one of the DC motor outputs. I've got the input. I stole a couple digital input lines, and I'm using that to keep track of the outputs from the encoder. And then I have just a simple potentiometer hooked up to the analog inputs. I power this thing up, make sure it's all the way zeroed out. I power it up. Nothing seems to be happening until I turn the potentiometer, and then you see the wheel turns. It's hard to see both at the same time here. See the wheel turns, and I've got it mapped so that one complete revolution of the wheel equals one complete revolution of the potentiometer, although it's not a complete revolution of the potentiometer. It's not very linear. But it seems to be working pretty well, and it'll hold its position. So if I put the potentiometer down and try to turn the wheel, I can actually feel it's fighting me. It's trying to turn it back in the opposite direction. So it gives you an incredibly high holding torque. I can move it. This thing at the moment suffers from a lot of mechanical jitter because there's no actual bearing there. It's just sort of a little plastic retainer that's holding the thing in place. If I put a ball bearing on, it'll be much smoother. And the problem is that if the encoder wheel slips out, then it's no longer able to keep track of where it is, so you can actually rotate it if you pull the ruling out. But other than that, other than those problems, it turns pretty well. It's hard to do this and hold the thing at the same time, but you get quite a bit of torque, and I'm holding the wheel and turning the potentiometer, and I'm squeezing pretty hard, but it's still able to rotate, and it'll try to seek to its position. So that's position integrator derivative control using inkjet parts. Whoa!